Good morning, good afternoon, and good evening, depending from where you are joining. Today, we are here with the next episode of Cloud Lunch and Learn, and we have a very notable guest, Turja from India. Hi, Turja, how are you doing?
I'm doing well, Elhan. How are you?
I'm doing well, thank you. And Turja is actually assistant director on Ernst& Young, and he has quite a good, interesting story about architecting in the cloud. And as you know, it's going to be a series of events, a series of sessions that he's going to present over the next 3 weeks. And we'll start with the Cloud Architect Part 1. So, Turja, give us a little bit insight into what you are planning to deliver over these 3 weeks.
Yeah, so as you said, Elhan, correctly, this is a three-part series across 3 weeks. In part one, I am mostly focusing on the foundations because, as you know, if somebody can get the foundation correct, then it is much easier to absorb new technologies. So today there is cloud, Kubernetes, tomorrow there will be something else. But if you have the fundamentals right, if you can capture the essence of the architecture, then it actually can help you in your journey to become a cloud architect. And this is what I will focus on mostly: what is architecture, what is cloud architecture, who are architects, why do we need architecture, what is agile architecture, and then I will keep kind of the foundation to start the journey.
That's great. That's really awesome. I believe there is a growing excitement to learn about that, and we have people who are joining to watch our show. And before we kick off and give the playground to you to do your magic here, I would like to tell to our all to our all viewers and people who are watching us. As you see on the screen, you have the link for Azure Architecture Certification, which is a series of study guides from Microsoft Learn. So if you are keen to learn about that, or start your journey of learning to become a Azure architect, please check those resources. They are created for you. Now, without any overdue, I'm going to give, please, to just share your screen and
Perfect.
yeah,
Okay, so let me share my screen. It should come up right now. So Alhan, can you just confirm you can see my screen?
yes, we can see it. So go
Perfect.
ahead, please.
Okay.
Yeah,
Okay, thank you. So welcome everybody to the first part of this three-part series on how to become a cloud architect. Okay. Firstly, warm thank you to Azure Dublin Meetup group and also the Cloud Lunch and Learn group for having me here and letting me present to this wonderful audience. Another a huge round of thanks to Hugo Barona, with whom I worked with on getting this set up, and Elhan for moderating this session. And again, congrats on your MVP award also, which you got today. Okay, let's get started. So let me first introduce you to two scenarios. So this is scenario one. Meet Sam. Sam has around 10 years of experience in IT as a sysadmin plus IT operator. Sam recently completed 3 cloud certification exams. With his newfound cloud knowledge, Sam attends a cloud architecture interview for a prestigious IT firm. Unfortunately, the interview does not go well. He is asked about topics he had not encountered in the cloud certification exams, and as a result, he gets rejected. So, this is scenario one. Let me also introduce you to scenario two. Meet Stephanie. She works as a lead developer in an IT company. She has developed quite a few products using cloud services. She is asked to take over the role of a cloud architect for a large scale application which will be published across the enterprise. She delivers the product, but it is neither scalable nor resilient enough, even though she is a great coder and had put the best programming standards in place. She loses the trust of the client and, as a consequence, loses the trust of her manager. So basically, I presented you two scenarios, one of Sam, another for Stephanie, but something went wrong in both of those scenarios, which resulted in failure. So the million dollar question is, what went wrong? What did they particularly do wrong? How can I or you prevent ourselves from doing the same mistakes? So, hopefully now I have your attention. Great. And let me briefly introduce myself. Currently, I'm working as an assistant director, as Ilhan said. But before that, I was leading the Cloud Center of Excellence team at Accenture. I have overall around 10 years of IT experience. But most importantly, and I want to focus on this for a moment, I successfully transitioned my career from being a C Sharp SQL developer to a cloud solution architect kind of role. So today, I am a full on cloud architect, cloud SME, where I help my clients and big enterprises in migrating and adopting the best standards that are available today, governance frameworks in the cloud. But I was not born in the cloud. So if you look at my journey that I have presented here, so when I started in Samsung research in 2012 till up to about 2016-17, I had zero idea of what is cloud. Even when I joined PwC, PricewaterhouseCoopers in 2015, I joined as a C Sharp SQL developer. It was only in 2017 that I got introduced to Amazon Web Services. Then between 2017 and 2018, I started working a little bit on a lot of Amazon services. For example, S3, Lambda, EC2, VPC, all of that. In 2018, I completed 3 AWS associate level certifications. And just a little while after that, I joined Accenture Cloud Center of Excellence team. Fast forward to 2022, I am in the cloud practice as an assistant director in EY. From 2018 to 2022, I have only focused on one and one thing, that is cloud technologies. I have done more than 40 certifications and have actually hands-on worked on cloud technologies. But if you focus on my journey, I will like to focus between 2017 and 18. That I consider my eureka moment when I got introduced to Amazon Web Services and I understood that this might just be the future and I need to jump on to this cloud bus. So what happened in 2017-18? One thing that happened was the realization that I needed to transition to something else, which is the most important thing according to me. That realization that I need to do something other than maybe what I am doing on a day-to-day basis at work is one of the most important things, because that will put the foundation for the next steps. Second, I documented my purpose or my future goals clearly. I knew I wanted to be a cloud solution architect. I documented that need very explicitly. Then I took appropriate steps from 2017 to enable my cloud journey, and that is what resulted in me in 2022 being a full on cloud architect in a big four company. I want to help you do the same in case you guys are also interested in making this transition. Also, another very important thing is that it doesn't necessarily matter where you are right now. All roads kind of lead to cloud architect if you have the passion and you put in the effort. So, for example, you might be in IT support today. Maybe you have moved on after 2 to 3 years to system engineering. Maybe you have taken on an additional role of a DBA. You can still become a cloud architect. Maybe you are a developer or a programmer. You have learned a little bit of Jenkins, GitLab, and right now you are in DevOps. Maybe you have done the Google Cloud Professional DevOps certification and become an SRE. You can still become a cloud architect. So all roads lead to cloud architect. The only thing that is needed is you need to start. And I want to help you on this journey to start, no matter where you are in the journey or where you are starting from, whichever role it is. Some housekeeping stuff. I will try to leave some time at the end to address your queries, but please keep them coming in the chat and Elhan will interrupt me and I will try to answer as many of them. And even if I cannot do all of them, I will personally reach out to you after the session and answer them as a promise. Okay, now let's get really started. So overall agenda across the 3 parts. So as you know, this is a 3-part series, part 1, part 2, part 3. In part 1, which we are doing now, we are mostly focusing on the foundation. As you can see, part 2 is built on part 1 and part 3 is built on part 2. So to really make the most of this series, you need to start from part 1 and then move upwards into part 2 and part 3. So now in part 1, I will mostly discuss what is architecture, who are architects, why do we need architecture, why should I personally become a cloud architect, what is agile architecture, what is cloud architecture. understand non-functional requirements, which is very important from an architectural perspective, and what is cloud native architecture. Okay, so this is the agenda for part one. So where are we today? Maybe we have some high level understanding of what cloud is. Where do we need to go? We need to come here. We need to come to this place where we know the steps to get started. But to come here, we actually need to take a few steps back. We need to start from here. We need to understand what is architecture. Then who are architects? Why do we need? Only then can we appreciate this journey and then start. So this is very important. Before you get into how to become a cloud architect, you need to first understand the basics. And getting the basics right is very important, more so now than ever. Because in this ever changing landscape of myriad technologies, the only possible way to stay relevant is if you have a strong foundation. So, for example, today there is Kubernetes, tomorrow there will be something else. But the trick here is that the fundamental, the essence of architecture has not changed that much over the years. And during this call, I will point out to you how it has not changed over the years. And I will point you to some basic fundamental attributes that if you can understand and capture and take home with you, then it will help you in your journey. But if we do not start with the basics, there is a huge chance that we might fall into one of the two scenarios that Sam and Stephanie fell into, which I mentioned at the beginning of the presentation. Okay, what is architecture? This is a $1 million question, right? So if you see the IEEE definition, which is a very complicated definition, it says architecture is fundamental organization of a system, its components, their relationships to each other, and the environment, and the principles guiding its design and evolution. Wait, what? I don't understand this definition. So the purpose of this talk is to break down this complex kind of things into simple attributes and concepts which are consumable and which I can take away with me at the end of this talk. So let me go into another definition by Grady Booch, who is considered one of the fathers of software architecture. He is a very well-known IBM fellow. So he defines architecture as a set of significant design decisions that shape the structure and the behavior of a system where significance is measured by cost of change. So we are coming somewhere. So we understand it has something to do with significant design decisions that shape the structure, and significance is measured by cost of change. But I'm still not very comfortable with this definition. This is not something very consumable to me. So now let me go to Martin Fowler's definition of architecture. He defines architecture as a set of design decisions that must be made early. So this is a nice definition, right? So any design decision that should be made early in your design phase or in your product delivery phase can be branded as architecture. So this is a good definition. But let me come to the definition by this guy, Matthew Parker, who was previously the global head of engineering at Pivotal Labs. So he defines architecture as decisions which are hard to reverse. And as a consequence, they need to be taken earlier because they're hard to reverse. So any decision that is hard to reverse is something you need to take early on your journey so that you do not have to reverse them, because reversing them constitutes of significant cost both in times of financial impact and effort. So let's give some examples. So say for example, I go with the second thing, whether to go with synchronous API based communication or use a event bus based asynchronous messaging system like RabbitMQ or AWS SQS. So this might sound complicated, but what I'm trying to say here is that whether I should go with a synchronous communication system or an asynchronous communication system. So this is a decision, a significant design decision that you need to take early on, because there is a huge cost associated with you reversing this decision further down the line. Similarly, another very simple thing which we do not consider as architecture. For example, what programming language do you use for your application development? So normally this does not look as an architectural decision, but this is also at a high level an architectural decision. Why? Say you start with C# and you have coded. After 1.5 years, you want to change to Java or Node.js. There is a huge cost associated with that refactoring. It is sometimes even impossible to do that. So any decision that has a lot of cost associated with it to change it in future and cannot be reversed easily can be thought of as an architectural decision, and that we can think of as the definition of architecture. So now we are getting somewhere. We have been able to define architecture in a simple kind of a sense as any design decision that cannot be reversed easily, and as a consequence needs to be taken early on in your life cycle so that you avoid the cost associated with changing the decision. But then what are architects? So we know architecture now, but who or what are architects? Here I am showing you a picture where you can see it's a cylinder. But to the person on the left, it looks like a circle. To the person on the right, it looks like a rectangle. But the reality is actually more complex. So it is neither a circle nor a rectangle. From these two viewpoints, it might look like that. But from a holistic viewpoint, you know that this is a cylinder. So this is very important in a solution design. So architects, whether it's cloud architect, solution architect, enterprise architect, whatever, have a holistic understanding of the system across a different spectrum of views and viewpoints. And they offer a different perspective of the system or design. So this is very important. So an architect will come into this scope and he will understand from an holistic perspective that this is neither a circle nor a rectangle. And he will help the developers, the programmers, the system administrators appreciate that from an holistic perspective, from an integration perspective across the enterprise landscape. He will give that kind of visibility. And that is where an architect adds value. Gregor Hope, who is a very well known enterprise strategist at AWS, has a lot of good books on architecture. He says that architect doesn't have to be the smartest person in the room. Instead, they make everyone else smart. This is something I like also a lot. As architects, our idea is to help others enable the system, but we will give them that extra visibility that they might be lacking. So, this is very important to understand. And if you see, for example, a cloud architect or a solution architect at the outside, you will look like, oh, this guy is a cloud architect. But underneath, maybe he has done a lot of roles in his journey. And he's an amalgamation of all those roles. He might know, do a little bit of IT support. He might know a little bit of DevOps. He might have been a solution designer, a data SME, even a business analyst, scrum master. It does not matter. A cloud architect is an amalgamation of all these scenarios, all these learnings that they got from all of these roles, which help them become a cloud architect today. And this kind of myriad kind of technologies and use cases that they have encountered gives them this extra ability to have a holistic view of the system, which is very, very important in architecture. But this is good. We know what is architecture. We know who or what are architects. But why do we need architecture? So I like this quote a lot. If you think good architecture is expensive, then try bad architecture. But again, this is a very good quote. But how do we tell anyone that architecture matters? How do we define the use case for having a good architecture in our system? This is very important. We need to have a valid business use case for having a strong architectural foundation in our design. Many times you will see software architects or cloud architects will take a high model ground and say, no, we need good architecture because that is the correct thing to do. That is our model obligation. That is very good, but a business does not care, very frankly. You need to show the business in their terms why architecture matters. And that is where you need to tell them that bad architecture or no architecture will slow down the ability of the customers to compete, as over time it will become harder and harder to ship new features. So let me explain this a little bit more because this is very important. If you see this graph, this was again by Martin Fowler and he calls this the design stamina hypothesis graph. So there are two lines here. The blue line is the no design or low design or less design, less architecture. The orange line is the good design or good architecture. So if you see initially, the blue line is a little bit ahead of the orange line. Why? Because in the initial few sprints, they did not do any architectural reviews. So they had more time to focus directly on the story points, which give functional value. So initially they were a little ahead, but over time, they are not able to add significant value and their velocity is decreasing. If they are touching one part of the code, some other part of the code is breaking. Because there is no design, there is no foundation, this is happening. If you contrast it with this orange line, maybe initially it is a little slow, But over time, you see that the velocity increases and you are able to cumulatively add more business value for your customers because your foundation is strong. If you are changing something in this part, nothing else breaks. You know what your code is doing, you have a good architecture, good documentation. So this is very important to understand when you are defining why I need architecture in my system, and that is why cloud architects come into the picture. But then there is another thing that is going on in the architecture community also. Today, everybody of us, we want agile and we have adopted agile, right? So agile means my requirements are not very clear upfront. That is what agile means at a high level, right? But then if do not have my requirements clear upfront, then how can I create an architecture for those requirements if the requirements are not even clear? So this is where agile architecture is being implemented today. So here you see two concepts, the immediate architecture and the architectural intent. The architectural intent is the overall intent of your system. It contains the principles, the practices, and the patterns that you want your target system to include. Whereas the immediate architecture is where you are right now, but both of them needs to be aligned. So for example, if your architectural intent is to create a loosely coupled distributed application, then your immediate architecture cannot be a monolith. It also has to be a microservice based application or a modular monolith. But yes, it might be missing some of the attributes. It might still not be secure enough. It might not be authenticated, authorized, but still it is aligned with the architectural intent. So that is very important. At every stage of your journey, your immediate architecture should be aligned with your architectural intent. And what is the architectural roadmap? It is the journey from immediate architecture to the architecture intent. So this you can consider as your roadmap. And a very interesting thing here that I would like to note is that the architectural intent is also something that is agile, meaning it is not written in stone. Over time, as you get more and more clarity, your architectural intent might also change a little bit here and there. But your immediate architecture has to finally converge onto your architectural intent. So this is at a high level, some concepts of agile architecture. But what does this have to do with me? That might be one of the questions you guys are asking. Why do you personally have to care about cloud architecture? Why would you want to become a cloud architect? So might be many reasons, but some of the top reasons that I felt when I want to think that why I am a cloud architect today. Number one, cloud adoption is increasing like crazy. If you see this 2021 Flexera State of the Cloud report, you can see 97% of the respondents have at least one type of cloud. This is a very high number. Out of 100 companies, 97 companies is using at least one cloud. So you understand that cloud is quickly becoming, is already maybe our future. Number two, companies are spending a lot of money on the cloud. The same report says that 31% of the enterprises are spending more than $12 million per year just on public cloud, which is a huge, huge number. And they need somebody to manage that infrastructure. So all the high paying jobs are kind of in cloud today. And the third reason, a 2020 survey by the job search engine Indeed says software architect is the best job, most both from the concept of a financial compensation along with say job satisfaction. And look around you, you will typically see that architects are even paid 5, sometimes even 10 times the salary of normal engineers, developers, system administrators, or programmers, which is true sometimes. Okay. So this can be some of the reasons for you to think very closely about your intention to become a cloud architect. Good. So now we have covered a lot, and I think we are getting somewhere. But the question is, I want to become a cloud architect. But what is cloud architecture? I know at a high level the concepts of cloud, but how do I define cloud architecture? How do I consume it in an easy to understandable way? So that is the, as I said, that is the recurring theme of my talks, to explain these things in easy to consume ways so that you can take it away with you after this talk ends. Okay. So what is cloud architecture? If you see this definition, this is a very complex definition. It is the way technology components combine to build a cloud in which resources are pooled through virtualization technology and shared across a network. The components of a cloud architecture include a lot of things, which is good. Okay. But I don't understand this definition. I cannot consume this definition. So now let me try a different analogy. At a high level, I believe if you can understand this analogy, then you understand the basics of cloud architecture because everything is kind of related to this thing. So this analogy is the analogy of pets versus cattle. So what are pets? Pet is a cat or a dog or something like that who we love, we individually care for, we name them, we feed them, we take care of them. Whereas a cattle is something, say, for example, in a farm of 10,000 cows, you have a cattle which you don't have an individual attraction or an individual connection with. So you normally don't care what is happening to that individual cow as long as you have another cow. So hypothetically saying, if in a farm of 10,000 cows, I take one cow and I replace it with another cow, whereas I am still maintaining the output of the farm, the milk output, say hypothetically, then nobody kind of cares about it, right? Because we do not have that individual attachment. So this is the pets versus cattle kind of thing. So pets as an individual connection, I take care of my pet, whereas cattle is kind of like a distant attachment. I care about it being there, but I don't have a personal connection with this thing. Now, if you think about it in a concept of infrastructure, okay. So if you see, for example, traditionally how our infrastructure or compute environments were maintained, people used to boast, system administrators used to boast that my VM is up for 20,000 days or something like that, right? So everybody used to take care of their server as if it was a pet. They used to log into the server, RDP or SSH into the server, patch that server, install software on the server. And every server used to be different from the other server. And this is something that Martin Fowler used to call snowflake servers, right? Every single server is different from the other server. There is no template as such from where you can recreate that server if that server goes down. And as such, you had to maintain that server. You had to ensure that that server is completely okay and healthy. But with the advent of cloud, with the advent of API based programmable infrastructure, unlimited elasticity, at least the concept or at least that assurance of unlimited elasticity, pay as you go billing, metered usage, API based programmable infrastructure, this concept has changed a little. So in the cloud, we want to think and we should think of our architecture or our infrastructure, at least the infrastructure architecture, as cattle, where we should have a template and we should be able to create our infrastructure from that template. Tomorrow, if for example, one of my server is down, I don't care. I just create another server using that same template and I have that assurance that both of these servers are completely identical. If I want to patch a server, if I want to install a software on that server, I just go to my basic setup, to my basic templating file, and then I just install my software on that file, basically maybe change the script or something, and then again rerun that pipeline, which creates another new virtual machine. So this is the fundamental concept, and this is it what leads to a lot of more attributes which we commonly associate with cloud, like scalability, resiliency, fault tolerance. But all of this is kind of related with this. Now you might ask, was this not even required in my on-prem? Yes, this requirement was there even earlier. But with the advent of cloud, the tool chains that it is providing, this kind of API based programmable infrastructure that it is providing, this unlimited content of compute, unlimited scope, pay as you go billing, and all of that, this is much more easier to consume. So, this is also another recurring thing that I will focus across my talk, is that cloud is nothing new as such. The attributes are new, the concepts are new, but the underlying thought process is still the same. We want scalability now, we will want scalability later also. We want this kind of cattle based infrastructure even in our on-prem, but it might have been a little bit more difficult to implement it there. With the advent of cloud, with the advent of API based infrastructure, pipelines, unlimited compute capacity, this is much more easy. So at a high level, I personally think if you understand this, if you can relate to this kind of a concept of this pets versus cattle, and if you think about this in every phase of your design, then automatically your architecture or your cloud architecture will be a better architecture. Another thing that I
Hi,
want to focus on.
hi, Turjak. I'll just bring a question from studio.
Okay.
it's on the screen. How important is to know computer networking for the cloud?
Is very important. So basically, there are many different types. Very quickly, I will answer, and then maybe I will take this answer question again at the end. So cloud networking is very important, and this is something I will tell from my personal experience. Before 2017, I have never SSH'd or RDP'd into a VM. I used to write my code in Visual Studio, and I knew that there was somebody magically will deploy it onto my VM. Okay, I never even had RDP. But when I got into cloud networking became more important for me. And basically, see, networking is a very difficult concept and a very vast concept, right? Very vast field. To get started with it, you might not need to learn everything. You might not need to learn how BGP routes override each other. You don't need to learn at that level. You can start at the understanding of VNet, subnet, backend, route tables, the very concepts. And cloud has made it much more easier. But yes, when something goes wrong, when, for example, that route is not working, that on-prem route is not getting propagated, that is where you need to deep dive. And I have seen network engineers who have worked with Cisco routers and switches successfully transition their role into cloud network engineers. That is what I'm saying. The basics are still kind of the same. It's only about revamping yourself and then going on to the next phase. But again, I might again, if we have some time at the end, we will again handle, maybe answer this question in a little bit more detail. Okay. So now, if you think about this thing, these are some of the non-functional requirements: scalability, reliability, efficiency, security, maintainability, extensibility, testability, observability, and there are many, many more. Performance, cost effectiveness. There are huge number of requirements, and these are not new requirements. We always wanted our applications to be scalable. We always wanted them to be reliable. And at a high level, if as a cloud architect or as a software architect, you can ensure that your design is kind of compliant with these attributes, then you are already doing the right thing. So if, for example, your design or your software is scalable even in on-prem, then there is a high chance when you migrate it into the cloud, it will be at a much better shape to take advantage of the cloud opportunities. If it is reliable, if it is fault tolerant, if, for example, one instance of your application goes down, still your application is up, so then it will be much easier for you to take that same application onto the cloud. So what I'm trying to focus here, and this is kind of the message that I want to pass on to the audience, is that don't think about cloud architecture as something alien, something extremely new. Obviously, you have a lot of cloud services, you need to know how to consume them. But at the very essence, you need to ensure that your architecture respects these fundamental requirements of scalability, reliability, efficiency, security. Obviously, implementing this has some more difficult levels you have to do to implement, say, security, to implement scalability. But the cloud service providers actually enable you, they give you the tool sets. For example, Azure gives you Azure scale sets, the AWS gives you auto scaling groups, which helps you create this kind of scalable infrastructures. So public cloud providers or even private cloud providers, new cloud native frameworks will give you the tools to implement these architectures, but you still need to respect them in your design. So this is something that is very important. So your implementation of these architectural attributes might vary from use case to use case. Somewhere for scalability, you might use auto scaling groups. Somewhere you might use Kubernetes pods, right? But if you can ensure that your architecture respects this set of constraints that I defined, the constraints like scalability, reliability, performance, then you can confidently claim that you have created a well architected design. So this is very important. And this is what I wanted to just, I was saying, even when I was answering that question, that even in the cloud, nothing has changed that much in a sense. Okay. At a high level, all the constraints or the quality attributes that you needed to maintain in your data center based applications are even relevant today, sometimes even more relevant than they were before. Because when you were not in the cloud, maybe sometimes you did not have to think about some of these things. Some of your data center stuff used to take care of that. But with the cloud, more responsibilities with us architects, that we can design well architected systems that can define, that can completely encompass these quality attributes that I have mentioned. That is very important. Moving or migrating to the cloud does not mean that you do not need to think about scalability or reliability anymore. There's some confusion I have sometimes seen in people who are getting started with the cloud. They think that, okay, I am right now using cloud, so everything comes by default. No. Obviously, the public cloud providers provide you a lot of services, a lot of easy ways, a lot of tool chains to do that. But the same constraints are present in the cloud. The toolchain available is more robust and easy to consume. And the cloud is a great place to create this kind of scalable architectures, but you still need to think about them in your design phase. And that is the idea I want to give to you throughout this presentation. So, for example, if you see this, what are everybody might, some of you might know this. These are the pillars of the AWS Well Architected framework. What is this? Reliability, security, operational excellence, performance efficiency, cost optimization, sustainability is a new addition. But if I even consider these five, can you just think that these all of them are kind of relating to the same quality attributes that I mentioned a little bit back? So these are not new things that are coming in the cloud. These are the same things that people were focusing on even in on-prem. So a cloud architect or any designer, system implementer who used to think about reliability in his on-premise system will still think about the same in his cloud, but yes, the tool chain will vary a little. So don't get overwhelmed with all of these cloud things, well architected frameworks. These are just extensions of what you already know, what you are already practicing. Only the tool chains have changed, and this gives you a much more freedom to implement new stuff in a way you could not have maybe in an on-premise environment. So this is the overall understanding. The cloud might be new, but the essence of architecture remains the same. This is the very important thing I want to focus. And similarly, cloud service providers like AWS, Azure, they will help our architects in building better solutions. So they will give you the tool chains. They will give you kind of the base framework, the services that are kind of will amplify your scalability, your reliability. As long as you are playing by the rules, you can create awesome solutions because the attributes that public cloud offer. So what, like infinite compute, pay as you go, they are very well aligned, and they will help you as architects in building solutions which can respect the quality attributes that we discussed before. I am harping on and on into this same topic because this is the most important thing that I want you guys to consume from this talk. And these are called non-functional requirements, which I mentioned to you. So normally in an architectural design, you have lots of requirements, functional, business, but these are non-functional requirements, quality attributes. Also, sometimes people call them elites because scalability, reliability, maintainability, all of that. Okay. Being a cloud architect, you should focus on defining, documenting, implementing, and then managing these NFRs of the system that you are designing. What is NFR? Non-functional requirement. What are non-functional requirements? Scalability, reliability, all that lot. And typically in a normal enterprise, this will be documented in your solution architecture documents. But is architecture just non-functional requirements? No. Architecture as an overall field of study is a huge thing, right? People spend their entire life just studying on architecture. It's not possible to go over everything in just maybe 15 to 20 minutes. Architecture also comprises business strategy, human dynamics, IT environment. But as a starting, someone who is starting, you need to focus, you need to narrow your focus. So to start, I think it's very good to start with something that is quantifiable. So when you are starting as a cloud architect, your journey, rather than thinking about how to anticipate human dynamics or how to anticipate business strategy, focus on creating a scalable architecture. Focus on creating a reliable architecture. These things are much more quantifiable, much more implementable. Good. Right now, we have kind of covered what is cloud architecture at a high level, right? So, but no such discussion in cloud can stay without cloud native architecture, right? So today, as you can see, cloud is kind of getting, you can say, overridden with cloud native, Kubernetes, Docker. So we at least need to define what is this cloud native architecture? Is it something very different? So Cornelia Davis, who was with Cloud Foundry, I think the VP, she was the VP and now is in Amazon Alexa team. She used to define cloud native as loosely coupled running in the cloud. So she used to say cloud is where you compute, cloud native is how you compute. So understand this, cloud native is how you compute. So cloud native is kind of composing of a few principles, right? So there are some principles which relate to cloud native architecture. What are they? They are single concern, high observability, image immutability, self-containment. But again, this is kind of not consumable enough for me. This is too high level, right? I mean, this is too complicated. I don't understand what is runtime confinement. I don't understand what is, say, for example, process disposability. But again, I want here to break it down into consumable inputs. At a high level, if you really think about it, the cloud native architecture principles that I showed you in the last slide, they are just extensions of the best practices or the standards which enforce the same non-functional requirements that we discussed. So what I'm trying to say here, I'm trying to say that cloud native architecture principles are just extensions of the same quality attributes or non-functional requirements that we handle in normal cloud architecture, but in a different way, maybe cloud native architecture. So let's take an example. One of the key principles of cloud native architecture is immutability. What does that mean? That means my infrastructure, my VM or whatever compute should not be modified in place after deployment. So say for example, I want to upgrade the version of a software. I should not RDP or SSH into my machine and update the software. I should not do that. What should I do? I should have a template. I should have a base image, some sort of script. I should change that script. I should run my automation pipeline, which will delete my VM and create a new VM. So this is what we refer to as immutability and immutable infrastructure. To have immutability, we must have an automated way of creating infrastructure. Otherwise, we cannot have immutability. So if we say that the infrastructure or the cloud native architecture is immutable, it means as a consequence that I have an automated pipeline to create or deploy a new instance of my application. This means that if my existing application is down, I can use that same pipeline to quickly create another instance, right? Meaning immutable infrastructure means that I have an automated way to create a new application. So I can use that automated pipeline to deploy my new application, new instance of my application, even if one of my existing instances go down. What does this mean? This means if my application goes down, I can quickly create another instance of my application, which is reliability. So that is what I'm trying to say. Immutability leads to reliability. And what is reliability? It was one of the non-functional requirements that we discussed earlier. So right now things are starting to close, right? So the same architectural attributes that we discussed earlier, which we should respect as cloud architects, we should understand, we should spend time on, they are basically extended as cloud native architecture principles at a high level. So simply put, cloud native application architectures are a way to build better applications which work better, scale better, they are more reliable and take full advantage of the cloud provided you play by the rules. So this is very important. You need to play by the rules. So the cloud service providers, and this is something you guys need to understand if you are already in the journey or if you want to take this journey of a cloud architect or cloud architecture, is that the platforms are there: AWS, Azure, GCP, cloud native platforms like Kubernetes, VMware. They will be there. They will give you all those building blocks that will help you create these awesome architectures. But you still need to architect your system correctly. And to do that, you still need to go back to your drawing board and think about the same quality attributes that you had been thinking maybe in an on-prem system also. So same scalability. Earlier, maybe you were doing scalability with something else. Now you might be doing with containers and Kubernetes. Earlier, you might have been doing fault tolerance with maybe highly available SQL clusters spread across regions. Now you might be doing it with, say, for example, Azure MySQL instances, DynamoDB, Cosmos DB. So the implementation might change, but the architectural constraints still stays the same. And this is where cloud architects like us, we come into play, we come into picture, and we try to fill in the gaps. And this is where we add value to the system. So in a nutshell, cloud native can be thought of as an approach to build and run applications that can leverage the advantages of the cloud computing model. And it is based on a lot of pillars. And cloud native in itself is a huge, huge journey. Okay. I mean, it's a continuous journey. I'm still learning on that journey. It includes some of the pillars like DevOps, microservices, containers, continuous delivery. Each of them can take maybe 6 months, 8 months to completely encompass. But to not get overwhelmed, okay. So if you see, this cloud native is a big topic, right? I mean, you have container, Dockers, Kubernetes, then you have observability, Prometheus, then you have GitOps like Argo City. But there is no point in getting overwhelmed. I always take a step back and try to go to the basics. If I see, okay, what is today Prometheus trying to do? What it is? Observability. Okay, observability is something I also needed earlier also, right? I also used to do maybe using normal logging libraries, something like that. Now I have to do it at a high level because my containers. Okay, what are containers? They're stateless. Stateless architecture is something I used to do in my on-prem applications also, so that I can deploy it easily across instances. So the same concepts that you had learned, you had done maybe as a sysadmin, maybe as a developer, maybe as a DevOps engineer, they are still relevant. You just need to brush them up a little, add that kind of a cloud flavor on top of that, and then you are ready for that next big jump onto a cloud architect role. So this is a high level mind map that I follow. So I always think that architecture is the bigger thing, within which cloud architecture is a subset, right? Within that cloud native architecture, I consider as another subset of even cloud architecture. But the main thing that I want everybody here to focus on is this basic, which is kind of at the crux. If you understand those basics, they will help you whether you are doing solution architecture, whether you're deploying an application across virtual machines or across containers. So that same quality attributes, that same concept of treating my infrastructure, treating my application as a cattle and not a pet. So that kind of those high level concepts, if you can imbibe them into your design, into your architecture, then you are automatically doing the right thing. You are automatically on the right path. And you need to focus on that rather than all of these new jargons. But yes, the implementations also matter and you should focus on them also. You need to only learning about statefulness, statelessness will not help you debug a Kubernetes pod that is kind of failing container not starting error in production. You need to understand the technologies and tools, but they will vary. Today there is Kubernetes, tomorrow earlier there was Mesos, there is Docker Swarm, tomorrow there will be something else. But scalability will be a requirement, maybe even 50, 100 years in the future also. So let's take a step back. Let's look at what we covered till now. So we started at what is architecture? Who are architects? Why do we need architecture? Why should I become a cloud architect? What is cloud architecture? And we finally ended with what is cloud native architecture. I spent a lot of time on the basics in this part one of this part three-part journey so that I can leverage this foundation to concentrate on actual guidelines on how you can start your journey in parts two and parts three. So this is kind of laying the foundation. So if you have understood what is architecture, why we think about architecture, all of this, then in part two, I will focus on actionable insights because all of this is talk, very frankly. So we need something that you can use to start your journey, right? This is good. Learning about architecture, knowing why architecture is important is good. But what concrete steps can I follow to actually start my journey? So that is what comes in parts two and parts three. But there's an overlying message. So there is no shortcut to becoming a cloud architect, right? So you cannot just say that, okay, is there any book I can learn and become a cloud architect? No. And the good thing is that people who have 4 years, 6 years, 2 years of experience, maybe doing something else, maybe you're a Linux sysadmin, maybe you're a DBA, none of that effort goes to waste. None of that. If you have that architectural mindset, none of that goes to waste. You can still use that and build on whatever you have learned and then start learning new things. So now coming back to the question. So I promised you that at the beginning of, I have showed you two scenarios, Sam and Stephanie. So both of them kind of failed. So we want to know what went wrong. So in case of Sam, even after doing some cloud certification exams, he could not crack the interview, right? So why? Because maybe because he could not understand how architecture works. He could not explain what kind of NFRs he will have to document in his solution architectural documents, how he will make architectural trade-offs. So these are things that I, for example, ask people when I interview them. And this is stuff I have been asked when I have interviewed for architecture positions. So cloud art certifications are an awesome thing, but they are not enough. You need something more. You need that extra sauce in your ingredients to get that coveted cloud architect kind of role. In scenario 2, Stephanie, she's a brilliant programmer, right? But just like I showed you in that picture, she has a she might have had a narrow viewpoint or perspective of the system. She might not have been able to appreciate the system from a holistic view. She might not been able to understand the intricacies of the design with respect to other enterprise systems, maybe SAP system, HR systems. So having a holistic view is equally important, if not more. Maybe this is why Stephanie failed in her journey. So this is the overall journey of a cloud architect. So right now we are kind of finishing part one. So this was getting the basics right. This is the most important from my perspective, because if you get the basics right, everything else follows. But in part two, we will discuss concrete actionable steps. This is also very important, because just having the basics will not get you that job, right? Basics is good, but you need actionable insight to work and create your kind of roadmap and kind of what I need to learn, what I need to follow, and stuff like that. And in part three, I will create kind of sample interview sessions and guidelines. So this is how I have thought of this journey of a cloud architect in three parts, one, two, and three. Sneak peek into part two, which will be in 7 days, I think in a week, same time. So we'll discuss actual actionable steps to enable the cloud journey. We will go over 10 concrete actions that helped me in my journey when I started. 10 concrete actionable steps. And then I will discuss tips and tricks to stay focused and not get overwhelmed with the abundance of knowledge. So, how to filter out the noise, how to not get overwhelmed, and how to stay focused on this journey to become a cloud architect. So, join me if you're free again on 9th March. And with this, you can contact me on LinkedIn if you want. And I really hope you enjoyed my presentation. Thank you.
Thank you, Turja. So here it was a great presentation. Thank you for going into the basics and details how to start an Azure Architect. Next, I would actually want to bring the questions from the studio that were there. So one of them you addressed about networking. Let's look at the next one, which is actually coming here. So it's coming from Gaurav. Will this discussion be available after this live session? And this is yes, it's a recorded session. You will have an access on Twitter or YouTube or LinkedIn. They are broadcasted there, so you can come back and rewatch it and put your questions there. I believe Turja would be more than happy to address them. Even if you put them after a few hours. So next one, we have another good feedback about this presentation. So there is like good appreciation coming from the studio. So thank you for this. And regarding the, I will just come back here that if you look into the chat, I also paste in the part two registration link so that you can go and register. Make sure that you don't forget about that and come and enjoy it next week. But Turja, speaking about as a cloud architect, when they start, now there's like actionable items they are going to list on the next one. But on the first part, in terms of as a becoming cloud architect, right? So would you advise somebody kind of put themselves into the shoes of, let's say they are still software developers or they are still doing some high level business development, right? Would you suggest them to put them into the shoes of cloud architect and think like they are already cloud architect and they are trying to solve a problem, or they are trying to actually do something? So what you would do adjust in terms of mentally changing the
Yeah,
approach and actually taking this role in a way that would develop themselves?
exactly. So let me give you an example. Say, for example, you are a system administrator, just a simple system administrator, and you have been asked to write a script to take the status of the backup of your virtual machines. Maybe your virtual machines are running in Azure. You need to generate a daily report that, okay, this is my VM, my backup succeeded, my backup failed. So normally, if you're from a developer mindset, you might just write a PowerShell script, right? And that script works, and then you give that script, and somebody's running it, and everything is okay. But this is where I said, and this is one of my actionable insights also actually in the part 2, where I will say, try to get a gig that gives you an architectural opportunity. And not always your team lead will give you that opportunity. You will have to find that opportunity. So say, for example, even in the script, when I was given this task, and I'm talking from my personal experience back in 2018 when I just started on Accenture, I started asking these questions to my solution architect at that time. Where will this script run? What if the compute which is running my script goes down? Where will I get my logs? What if there is a failure? How will I get alerted? So these are all questions where you are thinking about, well, okay, is my maybe the script does not need to be that scalable also, like a
Mhm.
web application, but at least it needs to be reliable, because your business users will every morning want that email, and if that script fails, that email fails, you don't get that email. So how do I get alerted? What if the virtual machine that is running that script gets patched that day at the time when my script was running? Should I put some sort of a queue mechanism and retry it, something like that? So these concepts, even for a very simple script, to make it a complete well architected kind of a framework script, you need to put in a lot of effort, and you can start asking these questions. And I agree 100% with you, Alan, that this is what I call the architectural mindset. And this is something I will focus a little bit more on part 2 and 3, is that I call this the architectural divide. Because going from this left phase where you are kind of like a developer, you are just writing code, pushing it into your repository, your unit test run, and you are gone, right? You are okay, you are happy, to this kind of a mindset where you think about everything. You just don't think about your code, you also think about where it is running, throttling, security, everything, every single quality attribute. That is what is an architecture.
Great. Thank you for giving that example from your previous experience, and I totally agree with that. Like getting beyond your day-to-day job and thinking holistically, and plus in a way that all these pillars that Turja listed, like reliability, scalability, availability, right? How it's gonna happen, and whenever failure happens, which or basically in my understanding, like if you simplify that really, Azure like cloud architect, it's all about once the failure is there, what's your plan? What's your game plan there, right? So if you plan for failure, you can become a good, I believe, architect, system architect, cloud architect. But if you plan for failure, because that's your job is to make sure that you have those pillars to address those concerns, and not just the components that are part of the system, right? So thank you for again to bringing that, and bringing those points, and a great session. Again, I put the part two link for registration. Please, everyone who attended this session, make this registration. In addition to that, I will just mention that our Cloud Launch and Learn has this URL here and QCR code. If you want to go and look into the cloud architecture learning passes on Microsoft, and I highly recommend everybody to click on that link or scan that QCR. That link is also posted on the chat, and get rolling. Get your If your dream job is to become architect, this is the session where you need to be, and this is the part one. Great introduction with Turja, and just put your questions there. And we come to the end of the session, but you can still, put that there. Turja is a great speaker. He will address your concerns, and thank you for joining. Again, thank you for spending your time here, and thank you, Turja, for a great session. It was really
Thanks a
enjoyable.
lot. Thanks a
Thank
lot.
you.
Thank you.